better capture the malicious node or malicious behaviors in vehicular networks. And we know that now the connected vehicles has become more and more widely deployed. At the same time, there's constantly some security issues or vulnerabilities for the connected vehicles domain. So we are trying to see whether or not we can use machine learning to help us better maintain the security and trust for the IoT and CPS in terms of the vehicular applications. So in this work, it's done by my graduate student and myself. So my graduate student who recently graduated, Wenjia, and we are looking at how we can use the AI technology to better evaluate and manage the trust of the vehicular networks. And also we are integrating the blockchain in the picture. And it's essentially a three-step process. So essentially, as the first step, we are trying to collect the local evidence. Essentially, there are the observations that each vehicle is maintaining and observing on their neighbor behaviors. And then those local evidences are shared among those vehicles to try to build up the trust. And then we are using the deep learning approach to perform the trust calculation and evolution. And finally, we are utilizing the blockchain to maintain and disseminate the local trust values so that we can try to achieve the global trust evaluation goal. And also more recently, I and my collaborators, Yu Hong from Santa Clara University and also Dr. Shui Song from Wayne State University, we are looking at how we can use the blockchain technology to build up a more trustworthy vehicular networks. So this is the first direction where we are looking at how we can use machine learning to help better secure the vehicular networks, or in general, the IoT and CPS applications. And then on the other direction, we also noticed that machine learning itself may also face some security threats issues. For instance, that picture that I got from Google image, you can see that on the left-hand side, it's just a very like cute pig, right? But if you add some noise at some given interval, then the machine learning classifier may misclassify that as an airliner. You can see that it makes no sense at all. But that clearly shows that the machine learning based approach, if you encounter some more smart adversary, in that case, that could be fooled, and then the performance will be severely degraded. So we are looking at the particular application domain, which is the malware detection for Android system, and we are thinking about how those adversarial example attacks could play a role in the detection process. And we can see that there are several different types of adversarial example attacks. For instance, evasion attack or data poisoning attack and exploration attack. So if any of those attacks is deployed, then the performance of the malware detectors will be severely impacted. And we are also looking at the solutions, how possibly we can try to bring back some of their detection power, because if we just make those adversary just occupy the performance, then obviously we won't be able to further classify properly of those malicious apps. So that's what I want to share, and I will be happy to participate in the discussion later on with other panelists. Thank you.
Thank you. Thank you, Dr. Li. I will now request Dr. Ray to share her perspective.
So, just this one.
Sure.
Yeah, I think so.
It is.
Share.
Oh, I see. They're probably seeing this, but
Yeah, that's fine. So, so good afternoon, everyone. So, my experience with the cyber
camera is off. Indrakshi, if you want to, I don't know whether you want to turn it on.
Say that once again.
The two microphones are not connected, so you have to stay close to the
Okay. Oh, okay. Yeah, there. So my experience with the cyber physical systems domain is in the realm of heavy vehicles and energy and IoT. So even when we think about the trucks that are going, they're not autonomous vehicles at this stage, just the simple trucks that are flying on the road. They are, they were built without any security in mind. And as a result, you can very easily hack into the tracks. And we did some demo experiment in our labs. And in 2016, actually, using some embedded control units, Arduino controllers, and we launched some attacks, denial of service attacks. And then later on a Cybertruck challenge in 2017-18, we were able to launch the same attacks on actual trucks. And as a result of which, and this we are talking of very, so what we find is that when so cyber physical systems, they were not cyber physical systems. Systems were designed without, them being in silos. People did not think about security. People did not think about attacks when these systems were designed. But with the modern, with everything being interconnected, which one did you press? Okay, this one. Yeah, next. Yeah. So with the systems being interconnected and connected to the network, and now the attack surface has drastically increased. So system level analytics is no longer sufficient. So we need to do systems analysis together with data analytics. And an attack, so different systems are interconnected, and an attack on one system can cause havoc on others. So first, what are the threats to CPI and iOS? There are some external threats. Foreign governments, insider threats, human errors, natural disasters, and the thing is that cyber physical systems forms a part of the nation's critical infrastructure, so they are prone to attacks. Can I use my computer? Yeah, next. Yeah. So IT versus cyber physical systems. When you're in the IT world, then you're just dealing with systems which have a lifespan of say 2-3 years. When you move on to the cyber physical systems, you are dealing with different kinds of systems having different lifespans. So, for example, if you're with the oil and natural gas, those things are not going to be torn down and replaced every 3 years. So you're dealing with a lot of legacy systems. Also, when we look at the IT world, integrity and confidentiality are important, but with cyber physical systems, availability and functionality, they must keep on operating. Those things become important. As a result, and they have become, so the solutions of the IT world don't really directly map. We are dealing with lots of proprietary and legacy components, poor inbuilt security, We have limited computing resources, say, for example, in the IoT devices, or even where you have timing constraints, such as embedded computers in the trucks. And so it's not possible for you to run anti-malware or antivirus software. Security patching may often be delayed because it's out, maybe it's out in the ocean if you're doing. And then you have many different vendors. So at one point, I think Northrop Grumman said they had 17,000 vendors actually, and at any point there were 4,000 vendors that were currently active. So supply chain security is a huge thing. And attacks on cyber-physical systems may happen over a very lengthy period of time. So all of these problems makes securing the cyber-physical systems difficult. But on the positive side of things, cyber-physical systems have a lot of redundancy, and so there is hope. In other words, you can design, even if something gets compromised, it may be possible to protect yourself from the effects of the attack by other redundant mechanisms. And we'll talk more about this tomorrow. We have a paper over here where how we exploit the resiliency. I think this will be later on. Yeah. Thank you. Thanks.
Thank you, Dr. Ray. Thank you, Dr. Ray. Then I have Dr. Ravi Sandhu, who will be sharing his perspective. Hopefully this should run out well. Huh? This is okay. This is that which.
I think I've seen you since, when was that? 2019 CODASPY, 3 years. Maybe they can't hear us.
Are you talking to me, ma'am?
No, I'm telling Professor Sandhu. We haven't seen anyone in person for about 3 years now.
Okay. So I'll be able to see the screen online. No? Okay. Screen share. Yes, sir.
Okay, you're in business? It's a pleasure to be here in person. Like Bhavani was saying, the last CODASPY was 2019 in Dallas, and it's been a long time. Still missing a lot of people. Bhavani didn't make it. Elisa didn't make it. Maanak didn't make it. And many others. So still not back up to full attendance. Anyway, it's very nice to be here. And thanks to the organizers for making it happen. I wasn't sure if this was going to be in person or what. But they were determined and they managed to do it. So congratulations to all of them. I have a very simple message here. I'm not going to get into too many technicalities. This is a very complicated domain. We have already heard many aspects about this domain. So I'll take all of that for granted. But if we want to make some progress here, we really have to start thinking holistically. Most of us work in silos. We develop expertise in silos and we love our silos. We enjoy living in them, but we cannot afford to continue going like that. We really need to bring at least these 4 elements of cybersecurity in some synergistic, convergent, holistic manner, whatever your favorite word might be, whatever the most fashionable word might be, And, we also have to bring in application context. This is a conference on application and data security and privacy, starting with application at the beginning. It's still not clear to me how to do this. And it's still something that as a community, we find it difficult to do. It's not easy to do. It's not easy to be holistic. Certainly as a single individual PI and investigator, that's a very, very tall order. How are you going to do it? Each of these is a very specialized and busy area. So maybe we can start a little small instead of trying to solve this problem for all of cybersecurity in a complex domain like IoT, CPS. Maybe we take access control and at least try to be holistic and convergent and synergistic within that. So that's something that we've been trying to do recently. We have a lot of access control models, ABAC, RBAC, REBAC, MAC, BAC, and a whole lot of things. Do we just keep one of these? Do we say one is the supreme and the others need to be all somehow subsumed or absorbed? Or do we try to see, which features are best used in which parts of our system? And that's what we are trying to do in our research. And I'm not going to get into the details here. We don't have enough time. This is not a paper presentation. But it does seem to me that each of these has some very fundamental idea. And if we can sort of get the core ideas and utilize them most effectively, then we have some chance of being able to make the best use of each of these ideas. And I will say, it's not in my slide, but let me come back to this. Would you think of the automatic teller machine network as an example of IoT CPS? Let me see a show of hands here. What do you think of the automatic teller machine network? It delivers cash, so there is a physical element to it. How many of you would think of it as an example of IoT CPS? Come on, let's have a show of hands. Okay, so how many of you have even thought about that before I asked this question? Okay, so, to me, the ATM network is something that we can take inspiration from. To me, it's a highly successful, widely deployed global infrastructure, which has actually got elements of CPS in it. And we don't teach it. We don't talk about it in our courses. We don't educate our graduate students and undergraduate students about it. And I think we're missing something there. And my last comment here, this was one question that Maanak had addressed specifically to me. He said, you're saying this, so how are you going to make this happen? So my first reaction is to take a smaller bite. So maybe do it within the scope of access control rather than all of cybersecurity. And my second comment there is we cannot do it alone as academia. We need to somehow involve or interact or learn from practitioners, from users. And we are sort of our community, I believe, is failing on that. So I'll leave it at that. Thank you.
The last starting presentation, I will request Dr. Bhavani, if she can share her screen, and then we will start our question session.
Okay, right. Can you see my screen?
Yes, ma'am.
Okay, so I think this is what happens when you go last. Everyone has covered what you wanted to talk about. So I'll just sort of reiterate some of the points that others have made, a little bit of some of the work that we've done. So I'm just focusing more on Internet of Transportation, security and privacy. And so I was sort of introduced to this field by Professor Alvaro Cardenas. He was a colleague at UT Dallas. And then we had a joint student we supervised, so around 5 years ago. But I didn't really understand a lot of things until this semester because I'm teaching a class on IoT security. So I think now I know a lot, understand at least I won't say a lot more, a little more of some of the challenges as Ravi mentioned. So we all know this, what Internet of Transportation is all about. And so Elisa talked quite a little bit about this, some of the challenges. So for example, we are focusing on autonomous vehicles. So some like camera, GPS, inertial measurement unit, and so on. So IMUs are susceptible to sound wave, GPS susceptible to spoofing signals. And so the challenge is that there's so little memory, there is not enough energy. So traditional techniques really don't work well. And some of the techniques that are coming, that have been developed, some of the papers that we've been reading in class, many of the papers are talking about these are things that need to be done, and there are some solutions, but I haven't seen really a whole lot of solutions. So some of the things that, in particular, it's mainly Alvaro's work. So we looked at autonomous vehicle security part, not so much privacy at the time. So he is focusing on, with Raul Quinenes, our joint PhD student, to build a reference monitor using a physics-based anomaly detection for ground and aerial autonomous vehicles. And in a way, that's a little bit hard for us computer scientists, because Alvaro is a control systems engineer as well as a computer scientist. So he really understands, he can model the physical systems. And so the algorithm that was developed, 3 parts: building a model offline of the vehicle's physical invariants, and then implementing an online tool to monitor expected and observed behavior for anomalies, and then raise an alarm if significant residual difference exists between the executions. So here is a detailed design. As you can see, Alvaro really and the student came up with this model. So this is, you really need to understand the system itself, the physical systems. So as Ravi also mentioned, this is not something that you can, a computer scientist can work. It's an interdisciplinary field. You got to work with the domain specialist and policy and application specialist and so on. So for offline pre-processing, AV's invariants were calculated using well-known nonlinear models, both for aerial and ground vehicles. And so accelerometer, gyroscope, and magnetometer sensor data on the X, Y, and Z axis. And then for the aerial vehicle positioning and steering for the ground vehicle. So online, I really wanted to get into machine learning, but Alvaro was, more sort of conservative, and he said, let's try with extended Kalman filters. And that's again nothing new, because the control engineers, systems engineers have been using Kalman filters for a very long time. So that's used to predict AV's physical behavior by estimating the unknown parameters from noisy input. And then the algorithm had 2 sections, one predicting and correcting the estimation, and then comparing it with sensor data. For anomaly detection, the Kusum algorithm is a statistical algorithm used to detect persistent attacks. And then, of course, an alarm is raised if the residual difference is larger than a predefined threshold. So this is our implementation. I know there's lack of time, so I won't go into details. We had aerial vehicles, it was drones. And so we looked at GPS spoofing and gyroscope attacks, and it was detected in 1.5 seconds and about 5.4% overhead. And the ground vehicles, we focused on detecting the visual attacks on the camera, and it was detected in 0.1 seconds, and the overhead was much smaller, 2.2%. And then the false alarms was approximately 2%. Okay. So this is something we got the idea from Elisa and Murat on policy-aware, privacy-aware, policy-based data management framework for the quantified self. So I was thinking that maybe that's something we could apply for the transportation system. So again, instead of healthcare data, social media data, and so on, we got radar, GPS, cameras, LiDAR, and then the small gadget in the car or plane or whatever. You have data collection, storage, analytics, and sharing. And what we are saying is policies have to guide the collection process, storage process, analytics process, and sharing process. And then, of course, some of the data in the cloud encrypted, and through services, you access the data. And in fact, Ravi talked about access control models, but Maribel has developed with a student a very good access control model, category-based access control model. And then we just finished a paper a couple of papers, actually, a more extensive paper on how you have policy-based data collection, storage, and analytics, and so on. And here we formalize the policies using these methods of rewriting systems. Okay, so this is really our work, but here are the directions. And I think everyone has talked about at least one or more of these directions. So again, we have said Internet of Transportation subject to attack. And then one of the things that Latifa has done, my colleague Latifa has done work is on streaming data. So sensor data is streaming. So he's done a lot of work on applying, developing machine learning for streaming data and developing an ensemble of models. But really his data is more network traffic data or financial data. But again, the challenge for us is these autonomous vehicles or IoT or whatever, there has to be energy conservation. So can our traditional stream techniques that we have applied for, say, financial and telecom data be applied to transportation data? And again, Internet of Transportation will depend heavily on data science, AI, ML. Elisa mentioned about that, and I think so. Also, Wenjia talked about it. And so driving without a human. And so it's going to depend on, without a doubt, AI, ML. Now, Murad talked about it also this morning in one of the sessions, and also Wenjia talked about adversary. Adversary will be learning the models used by the vehicles as well as learn about the data, and adversary will attempt to thwart the vehicle's learning process. So adversary has to adapt, and Murad mentioned that he and Alvaro are looking into that, adversarial machine learning for IoT systems. So that's another direction. And then can we develop privacy-aware policy-based data management framework? And what we had talked about, Elisa, Murad, and myself, for quantified self. But that framework, how can we apply it for Internet of Transportation and infrastructures? Again, everything has to be based on policies. And Ravi also mentioned about policies. And then is it possible to perform trustworthy machine learning? Right. So Latifa has looked at applying, using SGX, and I think Murata has done some work on using Intel's SGX platform for trustworthy machine learning. And the group from Oxford University, I was on a panel with them. They have advanced a lot on applying formal methods for machine learning. So similarly here, we are asking formal methods for IoT security. And Maribel has done some work in that area. And also Ravi has talked about access control. How does access control fit into all this? And Wenjia talked about blockchain. So I mentioned to you that I'm teaching a class on IoT security. So last Friday, my class was on blockchain IoT or IoT blockchain. How do you bring blockchain applications to IoT, or you can put it in another way, IoT applications in blockchain. So that's going to play an important role. And Indrakshi talked a little bit about real-time processing, right? And so again, this is time critical environments. So how do you integrate real-time processing with cybersecurity? So I did some work with the University of Virginia a long time ago, about 25 years ago, on integrating real-time and cybersecurity. And later, about 10, 15 years ago, I did some work jointly with UC Irvine. And so how do you then integrate it in an IoT environment? Plus, we are also applying AI ML. So all these things have to be integrated. And then Ravi mentioned about cybersecurity policy, but what about cybersecurity policy for IoT? Alvaro has discussed, so I said we have, sorry about the spelling, we have explored policy for power grid. So Alvaro worked with our Dean of Public Policy. She's really an expert. So they both got an NSF project where looking at policy issues for security for power grid in the country, Colombia. So the question then is, how can we bring policy into this IoT security environment? When we talk about policy, we computer scientists come up with really TOY policies. We've got to really work with policy experts to formulate real world policies. And then Ravi has a very good point in the sense that we cannot do this work in isolation. We've got to think about applications. So it's really truly an interdisciplinary field. It's not really only computer scientists, but computer scientists do have a lot to contribute. So that is my sort of, I think I finished my presentation within that 7 minutes. So that's it, Maanak.
Thank you, Dr. Thuraisingham, for your viewpoint. Now we're going to start with questions, and in the interest of time, we're going to change our script a little bit. So, there will be few questions from us, and we're going to open it up for the audience to share their viewpoint and to seek answers. So, Sudip.
Right. So the first question, Dr. Ray, is that when you're building these kind of systems, there is some human-computer interaction element. The NSF recently also had a PCL that asks people to pair up with SBE, social and behavior and economics folks to come up with certain solutions. Do you have any opinion on that? Do you see any good research direction that people can take in that?
So when you recently looking at IoT and the consumer side of IoT actually, and one of the things that we noticed was that I'll give you an example actually. The humans are of course unaware of what's going on. Like for example, we did an analysis of IoT apps, and we're looking at accessibility issues, security, privacy, and we were using existing tools actually to evaluate these apps, and we kind of did review on the counts of privacy, on the counts of accessibility, and just to give you an example, actually, we analyzed 455 mobile apps downloaded from Google Play Store. Of the 455 apps, we're looking at which one is giving more permissions than only by their own functionality. And it turns out a huge chunk of the apps were giving more for like access to the state of your phone. Everyone was giving accessing your location data. Those things were very common, as well as with respect to security, we found that some of the apps were transmitting your login credential. Actually, I think you mentioned that apps on those cases mobile and SDR too, and it was transmitting. So obviously the users are not aware of what's happening. So it's some level of the future and about what kind of provisioning features are happening. On the device side of things, we look at some of the smart home devices and we're analyzing the manual. There are many smoke detectors which have hidden microphones and actually aware, then of course they should be aware. On the other side of things, we're looking at how IoT can be used by the say elderly population. And so there cannot be IoT at this stage is not already. But in some sense, for them to be autonomous to the extent possible. And but sometimes that is not possible. So in such cases, how do we notify the users so that someone is spying on you, or how do we actually communicate the results of what's happening in a way that they understand they can take some action items, like say rebooting your router or something like that. And also for the elderly population, they need to have some semblance of control and there's need for delegation. And so how does this delegation take place? You want to take some of their permissions because there's always a proxy caregiver or something. All these issues will have to be
Thank you, Dr. Does anybody
Dr. Bhavani, Dr. Bertino.
Yeah, so it was hard to understand what was being said, but maybe could you tell me what the question was, please, Dr. Maanak?
Right. So, Dr. Thuraisingham, the question was that in IoT security research, there's a need for people to involve social and behavioral and other economists to help create better strategies, security strategies.
Yeah. So I think the answer, of course, is yes, because we have to bring in, again, risk analysis. And Murat has done a lot of work in that area. You have to look at the risks involved, and then you've got to look at the behavior, just like any other system, right? You've got to look at the behavior. How is the attacker going to attack? What is the attacker thinking? What are his or her goals or its goals? And then the societal aspects also have to play. I haven't really thought a lot about social aspects, but yes, it is really, as I said, interdisciplinary, not just between engineers and computer science, as social scientists, behavioral scientists. I mean, it's just, I don't think one person can do everything. So it's really an interdisciplinary. Maybe Elisa may have something else to add. Yeah.
Yeah, of course, those are relevant as with everything else in cybersecurity. I just wanted to add, though, that with IoT systems, you deal with a very complex environments where a lot of human users directly interact with those devices. And many human users are not expert at all. So this means that they may do a lot of misconfigurations that may lead to mistakes. And actually, you know, this is important. For example, I've been talking with people in industrial manufacturing, and when they have a complex configurations to be done, they would prefer a machine learning algorithm to do this configuration, rather than having the human operators doing that. Actually, they tell the operators, don't touch anything, don't change any parameter. That is going to be a problem, which again is important to have humans in the loop, but those systems, once humans interact a lot directly, may be a problem. So, because now, and again, you cannot expect that all users will be so expert to configure those devices. Therefore, usability will be even more important. But the best would be to really come up with AI techniques that can take care of those configurations.
And I'd just like to add one more thing. But before all of this, I think the basic IoT security 101 is to how to address all the memory limitations, energy conservation, all of those points have to be addressed. And I'm not seeing sort of viable solutions yet. Maybe there still are, and I still have to do more reading, but we really need research in that area.
Again, Bhavani, I agree, but in my view, those are technological limitations, and there are techniques to deal with that. The real problem, I think, when there will be more devices than humans on the planet. Yes. Therefore, somebody has to, that will be the real scalability problem. Because of the fact that some devices are very limited, actually for security may be good, because they can only do one function. Okay? So you can profile their behavior with an edge-assisted anomaly detector, and then you can see when the device is doing something strange. So that wouldn't be a problem, actually, because if you have a very rich devices, they can be hacked in many more ways, because they will run a lot of software. Okay, so, but the real problem, as I said before, will be continuous interaction with the environment, with the humans, with many more things around them. And that will be the real problem. And managing, therefore, them so that the overall security is assured.
Okay, thank you, Dr. Bertino and Dr. Thuraisingham. Anyone here want to add something?
You know, human device interaction is really significant for devices. But down the line, we're going to see a lot of devices. These things are going to be more and more autonomous, and human beings may lose control. I mean, if you want one of these dystopian science fiction futures, it's not out of reality that something will happen. And when most of the interaction is device to device, it may not even be visible. What's going on.
Point that I think explainability about what's happening in the from the AI point of view or from the interaction point of view is very important.
When we drive these complex cars, they're very comfortable. Now they drive themselves. And what we get one engine like the other. So essentially, I'm just taking charge us a lot of money. That's the level at which we engineers.
Okay, so I will put on our last question and then I will open up for the audience.
Yeah,
Yes, Dr. Thuraisingham.
Yeah, I have a question actually. I think maybe the other panelists can answer. I'm very interested because we just did some access control for IoT. We finished that module as well, a couple of lectures on that. So Ravi mentioned, Professor Sandhu talked about access control. So what sort of access control will work? Because remember, I don't think we can apply some of the traditional access control methods because of the limitations, memory limitations, and so on.
We come back to that question.
What access control methods you think?
Bhavani, we got your questions. We will come back to.
Pardon?
Okay. We'll come back to that.
Okay, okay, that's fine.
Okay, last question. Okay, so there has been a lot of talk on zero trust. Every cloud service provider, marketing people, they're selling zero trust technology, zero trust based security. I will request Dr. Sandhu to talk about what is this buzz about zero trust. Is it an obsession or what is your perspective on that?
When cloud computing became a big buzzword, now we all accept it. We all know what cloud computing is. It's been around 15 years at this point. But everyone in Silicon Valley took out all their PowerPoint decks and they literally cloud washed them. They called it cloud washing. You just take out your old deck and just put cloud all over the place. Cloud wash your pitch. And that's what's happening with zero trust. We are zero trusting everything. And it's just a marketing buzzword at this point. It may develop into some meaningful concept. But right now it is a marketing buzzword. And I really dislike the zero part because you cannot have zero trust. So it is just a wrong, foundationally wrong thing to be saying. It's like saying, zero debt. You're doing away with debt. You're going to have trust in your system. It's just a question of what is the appropriate trust, where is the trust. If you can understand where the trust in your system is lying and where you have to go around verifying that trust, that's a much more realistic approach. So when people say zero trust, they are just zeroing. You don't want anything.
Dr. Ray, Dr. Lee, you want to add something?
I kind of like what Dr. Sandhu said. I guess that nothing is good. It's just the context is changed and somehow we capture the context that it was actually. But how the concepts existed, right?
This would be good enough for what they're saying we should not be doing. We should not be relying on this concept. Yeah. I have no problem with that part. But the other thing from there, now maybe to have a rule of zero trust in my opinion. So how can you build? But the question is, who do you trust? How much you trust?
Dr. Bertino, Dr. Bhavani, you want to add something to this?
For some reason, we have hard time hearing.
So my question to you is, usually from a
0-1 notion of trust to non-binary notions of trust? Maybe do you have any cryptography altogether?
No, I think zero trust, part of it they have a score rate. You know, the way zero trust is defined, I'm going by the NIST document from I think, at least from my perspective, that's what it is.
Yeah, I need to understand more, think more about the zero trust. But Elisa, you've done some work on that, right?
Yeah, but I'm not sure what the comment by Ravi were. From what I could understand, Ravi says it's just a buzzword. Is that correct?
It has become a buzzword.
Yeah, I agree.
The way zero trust is defined in this document, it could use a lot more elaboration, and it is defined as a set of desirable principles without really prioritizing them or sort of putting them into packages that are meaningful and can be used together. So it needs a lot more work if you want to get any further. My fundamental problem with it still remains that it's not a desirable goal. I mean, zero. Saying the goal of medicine is to eliminate death, which I think is overdone. It should be to make us have a long, happy, good life. You know, to say that our goal is to eliminate death, maybe being unrealistic.
But the problem, yeah. The problem I see is with zero trust, right? So you don't trust, but you have to verify everything. Can we really verify everything in an IoT environment? That's the question. That's why I said I haven't thought much about it.
Even if you verify, you still have to trust something. If you do not trust even one bit of information, how are you going to verify it? If all your sensors are reporting fake data to you, how are you going to verify? So there has to be some trust. Even in cryptography, which is the most scientifically sound cybersecurity technology that we have. You have to make some assumptions and some trust.
Yeah, if I can add the comment.
The goal should be for us to understand where's the trust, and you know, how much are we relying on it, and how much are we willing to compensate for failure of it.
Dr. Bertino, you were trying to add something?
Yeah, I agree that we need to trust something. But if you look at research, I remember when I started, in 30 years ago, you were supposed to trust the operating system. And now today we learn that we cannot trust the operating systems. So I think, you have to trust something, but hopefully what you have to trust is not very huge. And second, applying zero trust may be very complicated, and especially for the IoT devices. What happened that, again, for very small devices, you can have a component which is sitting on the router or some edge, which can do some checks on those devices. Concerning the acquisition of data by IoT, by sensors, there has been a lot of work based, for example, on deploying redundant sensors. And therefore, even we did the work 10 years ago, how you using certain redundancy can verify that the values provided are correct. So today, there is a lot of work that we can do from that point of view, because you can really deploy a lot of alternative sources of data. You can cross-check the data. But in my view, coming up with zero trust architecture from the organization's point of view will not be trivial, because there is a legacy software. There are really a lot of issues. So, but at least people now realize that you need to check a little bit more, because if you look at real life attacks, you see that people don't apply even the most well-known security practices. At least with this zero trust, they will be forced to do a better job with managing security, to be honest. So.
Yeah, so the way I see it is there are, when you have billions of devices, it could be in all kinds of environments, and I think there are some devices where we cannot trust it at all. So we have to come up with some solution if we have to have truly secure IoT.
But Bhavani, if you know that you cannot trust a device, that's already a good starting point. You know that that device cannot be trusted.
Right.
Okay. But the problem is when you don't know whether you can trust a device or not, because that would be more problematic. So you think a device is good, is working properly, but again, there is a lot of work which has been done, at least for sensors, to be honest. So.
Thank you, Dr. Bhavani and Dr. Bertino. We have an audience question from Dr. Krishnan from UTS.
Hello, can you all hear me online? Online. All right. This is Ravi from UTSA. I have a question about balancing safety and security in the context of CPS and IoT systems. We're talking about smart transportation systems, smart grids. I don't know what next, but the classic version of balancing it was something like break glass, where emergency, you break the glass, break the open door. But with more complex systems, tremendously more complex systems, it's not even clear how you would integrate safety and cybersecurity and how it might conflict with each other. When I have to get out of my house, I want the garage door to open. I'll leave it at that. It's a question for the program.
Maybe we want to have the panelists in person to start with that. The question, Dr. Thuraisingham and Dr. Bertino, is how we balance between safety and security of IoT cyber physical systems. Mm-hmm. Who wants to chime in? Dr. Sandhu.
I mean, it's an excellent question, and it's something which is not the typical scope of what cybersecurity folks study. I was at a sort of industrial security meeting, and they had this phrase. They are concerned about things that drip versus things that go boom. They are much more worried about things that go boom rather than things that drip. If the pipeline is leak, leak can be deadly. That's what's leaking out versus the explosion. So there has to be some discipline of that kind. And we are not schooled. I'm not sure. We are, as it is, not able to deal with things that we are supposedly schooled in. Kind of expand our scope in that direction. Contribute.
So I can talk a little bit, not so much safety, but whenever you bring in security with, as I said, I did a little bit of work on real time and security. It's always a trade-off, right? Because sometimes time critical aspects are important, but they can violate with security. And so what happens if you're the central system that is making sure all the deadlines are met, that system is attacked. And so there's always a trade-off. So I suppose there has to be trade-off between safety and security if they are conflicting. And then it all depends on what the parameters are, because when you talk about trustworthiness, it includes privacy, security, trust, fairness, fault tolerance, integrity. But if you bring in everything in and want everything incorporated, then it could become an impossible task. So it depends on what levels that you want, and then make trade-offs. That's what I would say. And I haven't looked at safety versus security, but that's probably how I would attack that problem.
So from my point of view, I mean, you cannot do trade-off there because safety is critical, has to do with human, preventing human harm. Okay, so that's the real issue. People have shown that typical, if you have a security problem, this may result in a safety problem. Because, of course, if somebody acts inside of, for example, an implanted medical device, this may cause an harm to a person. But in the past, people came up with the breaking glass rule in emergency situations, certain security control could be bypassed, okay? So the question, we needed to engineer our system so that there could be an escape for a human in certain cases to override certain security controls. Now, depending on the environment, of course, you need to log and then to analyze whether the override was justified, okay? And if you are at your home, that's your home. And therefore, if you bypass the security, that's, that's okay with you. In other contexts, as overriding security can result in a damage. So you have to be very careful not to abuse this privilege. So in my view, in some cases, one can override, but then it has to be audited, okay? So that this privilege is not abused. But this is really an engineering, how you put your system together. And as I said before, what we really miss is not the security of a single device. Here we are talking about security of complex dynamic systems. And they have to be engineered so that collective security is ensured, and also the safety. So it's not a trivial problem, just because we are not talking about single device, okay? And the fact that they are organized in system has also advantages, though, because you can have a redundancy, get independent ways to collect the data, which will enable at the end to enhance both the security and the safety.
The problem I see, Elisa, is very good points you have raised, is that we already have different IoT systems. So I got involved for about 6 years on real-time systems for the AWACS, Airborne Warning and Control System. When I was at MITRE, we designed and developed systems from scratch with new technology, but we were focusing on real-time. We didn't look at security. We looked at real-time, a little bit fault tolerance, but at the end of the project, the project manager, the Air Force officer, he asked us, what about security? So then we sort of did a patched up job on security. So the worry is that with IoT systems, there are all these IoT devices, financial things, Internet of Things, transportation things, but they are really not engineering with safety and real time and security in mind. And then security may have to be an afterthought, or safety may have to be an afterthought. And that's what I'm a little concerned now. How do we solve, because they become legacy. So how do we solve that problem?
Yeah, that's true. I mean, we have the legacy issue, and unfortunately, the legacy will not only be the legacy of the software, it can be the legacy of the hardware. Yeah. But keep in mind that some of them may not be so expensive, so one can replace them easily. So for others, replacing may be expensive or unfeasible.
Dr. Ray, you want to have a question?
So I have just a comment to make about the interaction between security and safety. It was a project that we are doing with the Department of Energy, and we are looking into the problem of nuclear power plants security. The problem that we are very concerned about is a cyber attack that mimics the symptoms of a safety problem. And in a nuclear power plant, the problem is that there are human operators who are handling the kill switch. Because if there is a nuclear power melt, reactor meltdown, they have to just turn off, operate the switches themselves. So with the state-of-the-art anomaly detection, any types of models that we have or mechanisms that we have, we still cannot be 100% accurate. So this is a big problem. There is a cyber attack that mimics the safety problem. What do we do at those kind of times? So that's any thoughts on that one? What kind of advances we need to make in anomaly detection or intrusion detection kind of an environment, or to do it. And there is an interaction with human beings also at that point.
Mm-hmm.
Okay, I'm not sure I understood everything, but in my view, there is a lot of research in this area called digital twins, where you can have a kind of a simulation, emulation of a certain cyber physical system. And this would allow you to check what could be the consequences of certain actions, okay? And if you are able to do this in real time, you can control and perhaps block certain actions because they may lead to unsafe situations. That is a type of advance which could be very useful. Of course, this may be relevant for huge complex systems like transportations and so forth, but probably they already use similar tools already.
Okay, we can have one last question from the audience. It was supposed to be at 4:30. Let's not look at the time. My bread and butter are still in center. Let's take one more question from audience. Last question. Yes.
Thank you so much. I have a question actually. What are the security aspects of in a Mac layer that we are using for Mac layers?
So the question is, what are the security implications or security solutions at Mac layer in IoT domain? Anyone wants to address this question?
So this has to be answered by someone who really has good knowledge of the networking aspect. Oh, MAC layer means the media access layer, or you're talking about mandatory access control?
No, media access layer, most from the networking side.
Yeah.
That I wouldn't know specifically, but it would be interesting to see which would be the specific attacks. So from what I know, we work more at the NAS layer for cellular network, which is at the topmost layer. We don't deal much with the MAC layer, but at the physical layer, of course, a lot of people are working on those jamming attacks, but those have been around for a very long time. So, really one would need to look about which specific attacks those could be.
So there is a book I'm reading, I read before the class on IoT security. They touch upon, I can't answer that question, but they do touch upon security for the MAC layer and the different layers. So I think, yeah, so, and again, I think this conference, I think the people more are in the data and application security and privacy, right? So.
Okay, so I think
that's a good question.
Okay, any advice, for the entire panel, any advice for graduate students? We have a good number of grad students here. So, what directions they can focus on in their research, or anything that we are overlooking that needs more attention from the community?
I think this panel has addressed many research challenges collectively, all of us together. I know the situation seems a little depressing, but that means more challenges to overcome. So all I can say is a lot of interesting research problems for graduate students. I think what we discussed here could be enough for about 25-30 PhD thesis. Maybe I'm being a little bit optimistic, but that's how I feel.
I just give one piece of advice.
Yes, sir.
I had it on my side. Don't lose sight of the forest because of the trees. As graduate students, learn, you have to dig down, look into the leaves, find all problems that can be addressed in the conference paper and so on. And I have met many graduate students in my office. And they get so much that they get the tweets. So you have to make some effort to also understand the scope of where you're. Don't just be so narrow that you just focus on a few trees and all. So in terms of which particular trees you should be looking at.
Any other thing to add, Dr. Bertino, Dr. Ray, Dr. Li?
very important to me, management and response and the behavior. But then the also challenging part is that sometimes whether it's engineering or whether it's research, whether this kind of reducing my people better advice.
Okay, if I think we're gonna close our panel session. Thank you everyone for joining us today. There had been some goof-ups, but I think we had an interesting talk and everyone gained something from this. Hopefully we can have more research papers in the next iteration of CODASPY based on this panel. Thank you so much, everyone. Thank you, Dr. Bhavani, Dr. Bertino for joining us. Thank you.
Thank you for organizing this panel. Very good panel. Thank you.
Bye.